Boom. Hello and welcome back to Calculus 1. Nice. So we're going to continue section 5.2. We need to discuss the issues now that we have. We already seen that definite integrals are used to calculate area under the curve, and we calculated few of those. Let's do one more example just because we can. So here we go with integral, let's say 1 to 9 of square root of x dx. Now, what does this mean? If you look at the graph of x to the square root of x, it looks like this. Here is number 1. Let's say, is this number 9? 2, 3, 4, 5, 6, 7. Ah, no, that's 8. Here's 9. And what we are talking about is the area in here.
Is integral used for antiderivative, or is integral used for area?
Antiderivative is integral, and they compute area under the curve. So when it's definite integral. So the definite integral computes the area under the curve, and the meaning of this integral on the left is this green area that we see on the graph. Now, we know how to integrate, which is antiderivatives. So we are integrating 1 to 9 x to the 1/2 dx. We use the formula. We get x to the 3/2 divided by 3/2 computed from 1 to 9, which is 2/3 times 9 to the 3/2 minus 1 to the 3/2. We know that from yesterday it's f of b minus f of a. And now we compute this. We have 2/3. So you have square root of 9. Square root of 9 is 3. Squared is 27. Sorry, cubed is 27. Minus 1. We get 52 over 3. So area under the curve is 52 over 3 units squared. Whether it's inches squared, centimeters squared, meters squared, miles squared, whatever it is.
Where did the 2/3 come from?
From 3/2. When you flip double fraction. All right. Now, let's take a look at the area under the curve for y equals sine x on 0 to 2 pi. Let's see what you get.
Pythagorean flux. Is that
So, as usual, integral 0 to 2 pi. What did you find out? What's the area? You found 0, right? And you know that's wrong. So you found 0, but you know it's wrong because when you draw a sine graph from 0 to 2 pi, you know that you can color. Obviously, 0 areas cannot be colored. So this area exists, but the integral is not giving us the right value. So there is an issue, and this is the very important issue that we have to address. So let's first do the problem the way you probably did. So you got negative cosine x from 0 to 2 pi, and when you plug everything in, you got negative 1 plus 1, which turned out to be 0. Now, we know this is wrong. We know this is wrong. So how do we fix it?
So based on the textbook, wouldn't that be the net area based on
yeah, but how do we fix it to find the actual area? Absolute value of the part that is below x-axis. So we know that we can break this integral into number of integrals. So what I'm going to do is I'm going to say that the integral from 0 to 2 pi is integral from 0 to pi plus absolute value integral pi to 2 pi. So now when you write everything out and redo the problems, you have two integrals to compute, but you will get the right answer. So let's get busy. And you will have to do this every time. You will have to be careful whether the problem is asking you to compute the integral or to find the area. If the problem is saying to find the area, you actually have to be careful and make sure that the graph is not dipping below x-axis.
If it's just asking to compute the integral, then 0 is...
0 is the answer. If it says compute the integral or evaluate the integral, it's just 0. Find the area, you better get 4. Can we just do 2 times the first integral?
Yeah.
Yeah, we can, because they're exactly the same, right? The bump that goes above and the one that goes below, they're both the same size. But that's not going to work all the time, because sometimes the functions are not symmetric. So yeah, we can do the 2 times, in this case, 2 times the first integral, but in general, you can do that. All right, let's see another example.
How do you get 4?
2 plus 2 is 4.
Now we got 1 from each half.
You should get, you see how over here was 1 minus 1, right?
So that would be 2.
That should turn into 2, and then you have another one, so 2 plus 2 should be 4. Cosine, oh, cosine of pi, oh yes, it is 2, you're right. It's 2. The answer is 2. You're right. All right, problem 68. What's the area for y equals 4x minus 8 on negative 4 to 8?
Oh.
Why is my line thing still on? Like it keeps. What? It won't go away. Maybe I gotta restart my computer.
What's happening?
Like it won't go away. The volume thing. Oh, there you go.
Imagine if I said that's my
Oh no, I could be. Yeah. I mean, like, I came home late like 3 times when I was a young guy, and they told me, you know, not at the sunset, and you take the belt. My butt. Yeah. Honestly, though, dude, no way. Shit.
What's the answer? What's the area?
Going it down.
What's the first step? We have to draw. Yeah, we have to draw first to see if it goes up below the x-axis. So I'm going to use each square as 2 units, let's say. So the y-intercept is -8. It goes 4/1. So we first draw, and then from -4 to +8. So we see that we have negative area and positive area. Oh, look when we're closed now. Let me see. Hello? Yes? Oh, yes. Well, I'm in class. I thought there was an announcement by RVCC. Is it something quick? Is it something quick? Not yet, but I will. Okay. Yep, I will. All right. Thank you. Bye. Sure. Bye. I thought it was an announcement that will say that we are closed because of the motor main break or something. No, but it's not. It was someone else. Usually when I get a phone call from the school, it's just a closure of some kind. Anyway, so we graph first, and we see that we have negative and positive area, and we also see that the graph cuts through x-axis at 2. So we need 2 integrals, -4 to 2, 4x minus 8 dx, plus 2 to 8, 4x minus 8 dx. So, and then the first one is below x-axis, so the first one is the one that gets absolute value. We'll address those formulas. That if these swap, then the integral gets a minus in front. We'll talk about that. That's a formula. So we have x squared over 2, so it's 2x squared minus 8x, computed from -4 to 2 in absolute values, plus 2x squared minus 8x, computed from 2 to 8. Plug in 2, that's 8 plus 32. Sorry. 8 minus 16 minus another 16, and then minus and minus gives us plus 32. I'm getting positive number here. Plug in 2. 2 squared is 4 times 2 is 8. Minus 16, that's good. And then we have minus, plug in the lower number. 16 times 2 is 32. and then minus and minus gives me plus. And then there's also minus from the formula, right? Because the formula is f of b minus f of a. So when I am plugging this value, there is a negative from there, there is a negative from here, and then there is a negative from the formula. So that's 3 negatives in a row.
When you square the negative 4, though, does that negative go away?
Yes, and it did for this one. Because when I square negative 4, I get positive 16 times 2, but then there's this negative here, which makes it negative. So this should be it. And then plus 64 times 2, 128, minus 64, minus 8, and then plus 16. There we go. It's a lot of calculations. So this is going to be absolute value of 8 minus, that's a 64, 80, plus plus 8. So this is positive 8, and you add it here to get 30, you get 36, so 136 minus 64. So this is positive 72 plus, and this difference over here is going to be another 72, 144. All right, so few additional rules that come in handy with definite integrals. So we already seen the rule that integral a to b of f of x dx can be integral a to c f of x dx plus integral c to b f of x dx, where this c is in between a and b. No equal signs. So if c is in between a and b, then you can interrupt the integral at any point as long as you pick up at that point when you go on. And you can make as many of these cuts as you want. You can go from A to C, then from C to D, then from D to B. Right, so you can insert as many cuts. And for some problems that you need to find the area, and let's say the problem does this, right? Then you have to cut here, you have cut here, you can cut, and you have to cut a few times. So it will be one integral over here, another one over here, another one over here, another one over here, and another one over there, right? So there will be 5 integrals if it dips below like this, and you will have to use the formula to cut. Another problem, another property, really cool, integral a to a of f of x dx is 0, which is very easy to see because you would get f of a minus f of a at the end, right? Instead of having a b, if you have the same number, then it will be a same number minus the same number in the same function, so it equals to 0. Another cool property is that if you want to swap the limits, so for whatever reason, we'll see that in 5.5, sometimes when you do substitution, these limits flip. So you get to put minus a to b of f of x dx. So you can swap lower limit for upper limit as long as you put minus in front of the integral. And that's going to fix some of the problems later on. So these are all cool properties that you guys know. You know that you can kick out constants outside. So there's a lot of cool stuff that you can do. So that's definite integrals. the next section is the fundamental theorem of calculus. So we're going to restart the stream right away.